right, so now we're going to look at problem 1748. So it says a car traveling at 20 meters per second. So I'm going to write my information. So V naught is equal to 20 meters per second. Applies the brakes. The coefficient of static and kinetic friction between the tires and the road are 0.8. So mu sub S is equal to 0.8 and 0.5. And mu sub K is equal to 0.5. Determine the stopping distance. So if it comes to a stop, the final velocity is 0. If the car is able to stop as quickly as possible without skidding, and then determine the stopping distance if the car skids. Okay, so we want to find x, but the situation for finding x is A, if it doesn't, not skidding, and B, if it skids. Now the difference in these two things is the coefficient of friction. Which coefficient of friction are you going to use? Well, here for skidding, this means it's sliding. And once we understand rotation later on, this will make more sense. So if it's sliding, we're going to, so the rolling wheels are, the rolling wheels are instantaneously stationary at the point of contact. So normal stopping involves static friction, okay? And then, so for this one, we're going to use mu sub S. When the tires skid, which would be the second case, they're sliding on the road, so that means kinetic friction. So I just want to establish that right off, which we're going to use for A and B. All right. Now, after this, our free body diagram is going to be the same, because what we're going to do here is, if we're given V naught, we're given VF, and we want to find X. Okay, so let's think about this a second. V naught, VF, X. What other variable do we need to find? We need to then find the acceleration. And we're going to find the acceleration using our free body diagram. So once we find our acceleration, we're just going to say VF squared is equal to V naught squared plus 2AX. So this is going to kind of help us to say, what do we do first? All right, so now what we're going to do is we're going to draw our free body diagram. So here's our free body diagram. Now, again, what way is this moving? I'm going to make moving to the right. Why am I showing that? Because I need to establish my sign convention. Up and to the right is positive. So when I sum forces, I know what my sign convention is. So if the block is moving this way, the frictional force acts opposite the direction of motion. My force of weight is acting down, and my normal force is acting perpendicular to the surfaces in contact. Now, I know I want to find A from this. So A is going to be going in which direction? The X. So I know I should probably like sum forces in the X direction last, because that's going to give me my acceleration. But let's say I didn't know that. Let's say I wasn't really sure. So let's say what I did first was I summed forces in the X, and I said summation of X, f of X is equal to ma. Now I want to find this acceleration. So when I look at my free body diagram, the only force going in the F direction is negative F, and that's equal to ma. So if I rearrange that, I would get A is equal to negative F of F over m. Now, if I sum forces in the... Now, what is f of f? Well, I could sum forces vertically, and I could say summation of f of y is equal to ma. Is this block accelerating in the y direction? No, it's not even moving in the y direction. So this is 0. So now when I look at my free body diagram, I have Fn minus f of g is equal to 0. So f of n is equal to f of g, which is equal to mg. Well, what am I going to do with that? Well, now I'm going to do my third thing. So my third thing is I'm going to use the mu equation. So mu is equal to f of f over f of n. So f of f is equal to mu times f of n, which is equal to mu mg. So now I'm going to put this value in here. So this is going to be minus mu mg over m. So then I see that my m's cancel. So I see that, I kind of ran out of room here, that A is equal to minus mu g. So what am I going to do now? Well, I have two situations. So I'm going to do the stopping one. So for the stopping one, I know A is equal to minus mu g. So this is going to be minus 0.8 times 9.8. I don't make this negative because remember, the g is already negative in my free body diagram. I don't do a negative twice. So this acceleration comes out to be negative 7.84 meters per second squared. Then, to find the final velocity, remember I'm using the equation Vf squared is equal to V naught squared plus 2ax, and I want to solve for x. So Vf squared minus V naught squared over 2a is equal to x. So the final velocity is 0, so it's negative V naught squared over 2a. So it's negative 20 squared over 2 times negative 7.84. And do you see this negative in the numerator and denominator cancel? Because I'm measuring to the right, the stopping distance, shouldn't that be positive according to my sign convention? Yes. So that's why it's very important to be consistent with your sign convention. So when I do all this, x comes out to be 25.5 meters. Now I'm going to do the same thing with skidding. So with the skidding, A is equal to minus mu g. A is equal to minus 0.5 times 9.8 meters per second squared. So here the acceleration is negative 4.9. And again, because it's coming to a stop, the acceleration should always be negative. Now I'm going to go ahead, and I already rearranged this. So x is equal to negative V naught squared over 2a. So it's negative, again, 20 meters per second squared over 2 times negative 4.9 meters per second squared. So when I do all this, x comes out to be 41.67 meters. So first of all, if you write your work neatly, it's easy to follow. But in all these problems involving friction, what do we have to do? We have to draw a free body diagram. We have to take all our forces and have them go either in the direction of motion or perpendicular to that. So in this case, it's perpendicular and parallel to the surfaces in contact. And there's three things we're going to do. We're going to sum forces horizontally, we're going to sum forces vertically, and we're going to use the mu equation. Now, in this particular case, I didn't do them in the correct order, but I showed you if you do them out of order, like I did, and I sum forces in the x direction first, that's okay. Then I move on, I do this, and then I just come back to that. So it's okay. So those are the three things that you're going to do for every single problem.